Hey, Algebra 1, this is the second part of our video on compound inequalities, focusing on OR inequalities. Last video we talked about ANDs, now we're talking about OR inequalities. And the way we define OR inequalities is these have two separate inequalities with OR between them. Now that's the verbal way of writing it. The way that they look like is kind of the opposite of an AND inequality. Okay, what I mean by that is if we solve the two examples right here, so if I have 5x minus 2 is less than or equal to 7, or 2x plus 1 is greater than or equal to 5, what we find is that instead of having an overlapping region, we have two diverging regions, or regions that go in opposite directions, leaving a gap of numbers that aren't part of our solution set. Here's what I mean. So if I solve this compound inequality, this OR inequality, we want to solve each inequality on its own and take a look at their solution set. So if I look at the first one, 5x minus 2 is less than negative 7, I solve it like normal by adding 2 to both sides of the inequality. 5x minus 2 plus 2 crosses out the 2's, I'm left with just 5x, less than negative 7 plus 2 is negative 5. Okay, and then I go ahead and divide by 5 on both sides of the inequality. That leaves me with x is less than negative 1. Okay, so all my numbers less than negative 1 are the first condition here. If I solve the second one, once again, same sort of process. Solve it like it's an equation. So 2x plus 1 is greater than 5. Start by subtracting 1 from both sides. So 2x plus 1 take away 1 crosses out the 1's because that gives me 0. So 2x is greater than 4. And then just like in the last example, I'm going to go ahead and divide by my coefficient of 2, reduce everything by 2. That gives me x is greater than 2. Okay, so my two conditions is that I'm looking at all my numbers that are less than negative 1 or that are greater than 2. So when I go to construct my number line representing this compound inequality, a couple things happen. First of all, let's say negative 1 is here, positive 2 is here. When I go to graph these, anything less than negative 1, once again put an open circle over it, indicating we don't include it, and then everything to the left gets shaded in. And if I graph all my numbers greater than 2, open circle, and then everything to the right. So we could literally classify this as all my real numbers, or all numbers that aren't between negative 1 and 2. See how it's kind of normally for an AND inequality, it would be everything between negative 1 and 2, but now we're looking at everything outside of those two numbers. Okay? Another example, let's say we look at 2x minus 2 is less than or equal to negative 8, or 5x plus 1 is greater than 5. So we solve these like normal. Okay, I'm going to put my boundary line here so we don't get confused. We solve these individually, so I add 2 to both sides of the inequality. 2's cancel. I got 2x is less than or equal to negative 8 plus 2 is negative 6. Okay, so 2 times a number is less than or equal to negative 6. We want to get a clear idea of what that number is, so I divide by 2. It gives me x is less than or equal to negative 3. Okay, so all my numbers less than or equal to negative 3 are included here. I go over to the second example. 4x plus 1 is greater than 5. Subtract 1 from both sides of the inequality, like it's an equation. 4x plus 1, take away 1. 1's cancel, I'm left with just 4x. Greater than 5 minus 1 is 4. And then, just like before, we solve it by dividing both sides by 4. I get x is greater than 1. And then when I go to graph it, once again, I'm putting two inequalities on the same graph, starting with negative 3 and then positive 1. When I go to graph it, because it's less, all my numbers less than or equal to negative 3, I'm going to fill this in and then shade to the left. And then if I do the other one, that's a greater than 1, so all my numbers greater than 1, and that's going to be right here. Okay, so once again, that's how we graph an OR compound inequality. All right, let's do one more here. So we have negative 3x minus 2 is greater than negative 8, or x minus 1 is greater than 5. If I go to solve this, once again, solving the first one to the left, I'm going to start by adding 2 to both sides of the inequality. So negative 3x minus 2 plus 2 causes my 2's to cancel, left with just negative 3x. Negative 8 plus 2 is negative 6. Sign still stays the same, it's still greater than. When I go to divide by my coefficient of negative 3, I get 3's to cancel, I'm left with x here, and a positive 2 on the right side, because negative 6 divided by negative 3 is a positive 2, but I have to switch my sign because I divide by a negative number. Okay, so there's 1. The next one, if I add 1 to both sides, this one's a little bit easier, it's just a one step. X minus 1 plus 1 causes these to cancel, I'm left with x is greater than 6. Okay, so when I go to graph it, construct my number line like usual. And got 2 here, all my numbers less than 2, or my number is greater than 6. Well, that's easy because we can do less than 2 goes this way, and then greater than 6 goes this way. All right, very good. So, all right, guys, so you've seen how to graph and inequalities and or inequalities. Make sure you watch the next video when we have some special cases to solve inequalities. We'll see you next time.